This project is Hydropower Prospector by Jeff McCarty and Steve Hall. Our project is Reservoir Builder, because that's exactly what you're going to be doing in this project. So in order to begin, we're going to want to bring in a DEM or other file type with elevations. So we go ahead and click Add Elevations right here. We have a DEM. We'll go ahead and choose it. So you can see it imports the DEM right into here. We've got our map layers, so if you choose to turn it on or off, you completely can. The next thing that you want to do is you want to add a dam so we can build a reservoir. We'll go ahead and add a dam, and it will prompt you. Click on the map to draw a polyline. Double click to stop. We'll select OK. And I will go ahead and I will draw a dam, let's say right here. Oops, select the layer first. Now it's prompting us to input the height of our dam. And we can do that right here. We'll say OK. We'll say 100. Now, the units up here are going to be the same units that's associated with your DEM, so be sure you are familiar with what the units are. And you'll click Input the dam height. And the next thing we're going to want to do is select the reservoir location by drawing a polygon around it. So, we'll start here by clicking and enclosing all portions of that reservoir area. Double click to finish, and then we'll get an output. And right here we've got the surface area and the volume of our reservoir. And this is the area that it's enclosed. And you can see from here you can turn on and off each layer. So you have a little bit of functionality there. The last thing that we're interested in doing is the save feature. So we can go ahead and we can just save our file to whatever we like. We'll go ahead and we'll just save it as res1 for convenience sake. Click save, and it will be loaded into a text file, all that information. Also, you can see in the project that we have all these layers here on the left. You've got a little bit of functionality with panning and zooming of the project. You can go up here to this menu bar and pan and even zoom in on your area of interest. Just some added functionality for the user. Also, as part of the project, when you click Save Dam, it saves that reservoir file just like we showed you. Now, if you wanted to access it later, that you definitely can. I'll go ahead and show you that right now. We saved the file right here. You can double click to open, and you can access the information at your leisure. It'll tell you the dam height, the elevation relative to sea level, and then the surface area and the volume.
Okay, now that Steve has gone through that riveting demonstration, I will get to the even more riveting part, which is our code. I know this is what you all have been looking forward to, so I'll just get right into it. The first thing Steve really demonstrated was the need to add an elevation, or add elevations into our map. So that is done by clicking on that button. Here we have the code for the Add Elevations Click event. Basically all it does is allows the user to load in a raster layer of some sort and adds it to the map. After that, we'll go down a little bit. We saw that we needed to add a dam. We want the user to be able to determine where the dam would be located. So we have this message box telling the user what to do. There's the text. And what it then does is makes this variable amdigitizing true. So that's important because once the user starts clicking in the map area, those clicks will cause a prompt. So down here, when you click in the map area, it will ask if this amdigitizing is true. It was false before, but now it's true. Do this. Basically, it's allowing the user to click different points, keeps track of those coordinates, so they can create a polyline. The information box told them to double click when they were finished, so Down here we have what happens when you double click in the map area. Same thing, am digitizing is true still. So it tells the program to end the line, makes am digitizing false, so as you click around it won't keep trying to do these things. And then with those different points that it's been keeping track of, it creates a polyline with this code right here, uses the projection that was used for the DEM that they brought in, and adds that feature with that projection. Yeah, it then, since what happens, we want the user to know what they should do once they are finished drawing that line, it also then prompts this message box, which tells the user what to do next, which is input the dam height in the text box and click on that button to input the dam height. Okay, continuing on. So once the user is prompted to input all that information into the dam height, they'll want to click on the dam height button. So let's go down to the code for that. Here we are, dam height button, click. All it does is captures that input that they have used so that we can use it later, or that they've given us so that we can use it later, and calls this function create raster, which convenient enough is right there below it. So basically this goes through and does all the different raster calculations that you need to do. So first off, it wants to take the original raster the user provided, and then also the so first it wants to create a new raster which is just below the polyline that the user created. This is important because we need the lowest elevation along that line so that we know the elevation of the top of the dam, because the user just input a height of the dam. It is not relative to the elevations of the DEM itself. So we create that, basically a line of a raster using this complicated code, going through each cell and seeing if it intersects with the line and stuff like that. Big pain. Took forever to figure that part out. We then want to use that that min value, which we have put right here, and add it to, or add the dam height to it, so we know what the dam elevation is right there. With that, we create a new raster where all the raster values are at that dam elevation. This is because we want to use that raster and in the next portion right here. So we take that raster of single elevations at the dam elevation and then subtract the user's original DEM, which is done right here. The reason we want to do this is because we want to see, this will cause values that, elevation values that are below that dam elevation to become positive, and those that are above to become negative. We then just give those, the positive and negative values, a value of 0 or 1, just so we know where the possibility for the reservoir is and where it is not possible because of the elevation. With that, all those calculations completed, we then want to know from the user where they are planning on putting the reservoir. So we have all these possibilities. So we give them a little message box telling them to encircle their reservoir location, which they are able to see in the map window as Steve demonstrated, starting on one end of the dam line that they created, circling around and going to the other end of the line. This lets us know, or this then lets us clip that portion of the reservoir possibilities to show the actual reservoir, what will be used for calculations and such. So once the user has done all of that, so they've created okay, so once all those raster calculations have been done, we want the user to be able to encircle the area of the reservoir. So currently we just have a raster that shows all the possibilities for where a reservoir could be, where the reservoir would be at the dam elevation they've provided, but we want them to put a polygon around where they actually know the reservoir will be. So that's what this message box does, tells them what to do. Start by clicking on one end of the dam line, go around the area of the reservoir, and end on the other end of that line. This then, before they start clicking, this res area variable has become true. This is important because clicking on the map will come back up to our map clicking events. So just as before, just like the digitizing was looking to see if it was true, it's looking to see if res area is true. It now is, so it goes and starts allowing them to click different points, creating a polygon around on the map. Once they double click again, it sees that res area is true right here, so it allows them to end that and create the polygon itself. Causes res area to become false, so they can't keep clicking everywhere, and then adds that polygon to the map. It then goes to this create res raster function, which is the next important part of our code. So let's skip down to that. Here we are. So create res raster right here. Once that starts getting implemented, it goes, this clips the polygon with the end result of all those raster calculations we had, so that it creates a new raster, this final res raster, that is the same as the last raster, which was this R5, except it has been clipped, so it's only the portion that's inside of the polygon. It then calls this res calcs. Now that we have where our reservoir will be, this res calcs function does all the calculations that we want, including surface area of the reservoir and volume of the reservoir. Goes through a little process of different intersections, or finding the values of the reservoir cells, so that it knows how high the water is in that given cell. This then allows us to, right here, find the area of those cells in the reservoir. So we have each cell height, each cell width, and the total number of cells in that reservoir. That gives us surface area, and the volume is called some of the res cell heights. Allows us to add the values of that reservoir cell and multiply it and add them on to this sum of the cell heights, which then is multiplied to the area of the cells, giving us a volume. Then we have that message box that popped up telling us what those values are, in case the user wants to know right away. And then finally, to end everything, we are allowed to save that information. I know it's kind of unorganized, the save is towards the top, but that's how it goes. So here we go, clicking the save button creates this text file, which is created, allows user to choose the name of it, where it'll be. It has to be a text file, and then writes the information to that file and closes. And that is the extent of our code.